Warm welcome students. Today I am going to present here from the subject Engineering Graphics a topic called Isometric Projection, and here I am going to take the topic Frustum of a Hexagonal Pyramid. I am going to show you how to solve a problem in isometric projection of frustum of a hexagonal pyramid. So first let us try to have a small introduction about the term frustum of a solid. So when we call a solid as a frustum, it means the cutting plane is being parallel to HP or VP. It may be either a horizontal cutting plane or a vertical cutting plane which is cutting the solid. Whenever a horizontal cutting plane or a vertical cutting plane cuts a solid, then we call that solid as a frustum of that particular solid. Here we are going to consider a frustum of a hexagonal pyramid. On the other hand, when we use a cutting plane as a inclined to HP or VP, any other reference plane, whenever the cutting plane is being inclined, then that particular solid, whenever we use a cutting plane inclined cutting plane to cut a solid, then that cutting solid will be called as a truncated solid. So there are two different concepts over here, and today we are going to see about a frustum of a hexagonal pyramid. So this is a problem which we are going to solve today. So we are going to draw an isometric projection of a frustum of hexagonal pyramid of side as given in the problem 20 mm and axis height going to be 95 mm, and it is resting on its base on HP, and the edge of the base is being parallel to VP. So the edge of the base will be parallel to VP. Here the edge of the base is given to be, one of the edge of the base is given to be parallel to VP, and here the information about the cutting plane is also given in the problem. A horizontal cutting plane cuts a pyramid. It cuts a pyramid and it passes through a point in the axis at a distance of 80 mm from the base. So from the base at a distance of 80 mm, the cutting plane, the horizontal cutting plane cuts a pyramid from the base at a distance of 80 mm. So this is what given in the problem. Here they have asked us to draw an isometric projection for this particular solid, that is frustum of hexagonal pyramid. So now we shall move to the solution. Here the solution is given. So this is a way how do we solve this problem. For this problem we are going to draw the front view and top view. Here the front view and top view has already been drawn for our easy understanding. Here the problem is given as hexagonal pyramid. The hexagonal pyramid of side 35 mm and the height, axis height is given to be 95 mm, and the horizontal cutting plane is cutting the solid at a distance of 80 mm from the base. So as shown over here, you can see from the base 80 mm the horizontal cutting plane cuts a solid. Okay, and here the hexagonal pyramid with a base parallel to VP is also given in the problem. So we have drawn the hexagon parallel to the reference plane. 5, 4 and 1, 2 are the edges being drawn parallel to vertical plane, and we have also drawn the front view, which is going to be the triangle, and that triangle is cut from the base at a distance of 80 mm, and there the triangle is shown in the front view. And now for drawing isometric view, whenever we are going to draw an isometric view, we need to draw the isometric axis on both sides, which will be taken at an angle of 30 degree. So this is what we generally do whenever whatever the shape of the solid which is present in our top view, we always enclose it in a box. So likewise we have enclosed this hexagon shape as given in the top view, as this problem is a hexagonal pyramid. So the top view is a hexagon. So now we enclose this hexagon in a box. ABCD is the box which has been drawn in order to enclose this hexagon shape. So this box is being constructed here in this isometric projection. So we have to draw this box AB, and this side it is going to be BC, and we need to draw parallel to BC, and that will be AD, and parallel to AB we need to draw CD. So this will be the box drawn in isometric axis from which has been transferred from our top view. This AB, the side measurement must be taken from this top view. BC, CD and AD, all the length are to be measured from the top view, and it has to be transferred to our isometric projection. And while we draw this isometric projection, while we draw this, we need to take 30 degree angle on both the sides. We need to keep the box, or we need to draw the box in such a way that this AB and BC will be at an angle of 30 degree to the drawn horizontal or reference line. Okay, so that is what we have drawn it over here. You can see that AB, BC and CD as well as AD. So that is the box which has been drawn as in the top view, sorry. And we mark the points, or we mark the label in the top view in small letters, while we mark the same label in isometric projection, we mark it with capital letters. You can see that clearly. We have shown all the places the points are being indicated by capital letters, capital A, capital B, capital C and capital D. So capital A, B, C, D is the box which has to be drawn with the along the isometric axis. So after drawing this box, what we have to do is we need to draw the, as it is a frustum of pyramid, we can draw the height. As the height of the frustum is given in the problem as 80 mm. So what we can do is we can draw the height from each of the points, from A, from D and from C as well as from B. We can draw the height from each of these points equal to 80 mm. So when we draw from these points A, B, C and D to a height of 80 mm as given in the problem. They have already given the height of the the place where the horizontal cutting plane cuts the solid is at a height of 80 mm from the base. So we can draw 80 mm from all the 4 base points, and we can join all those points at the top, and in the top we can name it as A1, B1, C1, D1 respectively. So at the top we have named the same box which is having an altitude of 80 mm, and it has been named with A1, B1, C1 and D1 as we have drawn it over here. Here the complete diagram is shown here in isometric projection. The complete solution is available here. So we will see how to draw this complete solution. So that is what we are going to explain it in this session. So now we need to transfer each and every content which is available in our top view to this isometric view. So the cutting plane here, already the cutting plane I told you, this is a horizontal cutting plane, and which will be having some points. The horizontal cutting plane will be having some points as indicated over here. You can see here the cutting plane, the hexagonal shape is being labeled with a name 1, 2, 3, 4, 5 and 6. As a hexagon is having 6 points, 6 corners, it has been named by 6, 1, 2, 3, 4, 5 and 6 in its label. And now the cutting points are named from here 7, 8, 9, 10, 11 and 12. So that is what from here, from the cutting plane, we can project it to the top view. As we know, generally the cutting plane, I will show you here, it is like this, the cutting plane. So here the cutting plane points are to be marked. So the cutting plane points are being marked over here, and the points will be just a minute. Okay, so here the cutting plane points are being indicated as 7, 8, 9, 10, 11, 12. So there are 6 cutting points which are being indicated over here. From these 4 points, we are able to get 6 cutting points. So at the left extreme point, we will be having only 1 point, that is 3 or 6. You can see here the point will be 6 dash and here the point will be 3 dash. So the left extreme as well as in the right extreme, there are only 1 corner point. So the cutting point here in the top there also we will have only 1 point. So and that point is going to be 12, and here that cutting point is going to be 9. But in the here in between the left extreme and right extreme, there are 2 corner points, and those corner points will have 2 edges. So there is edge 1 and 5. Here we can see 2 and 4. So this edge will have 2 corner points. One is 1 and 5, and here it is going to be 2 and 4. So here the cutting points will be 2. In these points we will get 2 cutting points. One will be 7, and inside the bracket it is going to be 11, and similarly here it is going to be 8, and inside the bracket it is going to be 10. So those are the 6 cutting points as shown over here, where can be indicated over here. Okay, 12 in the left extreme, 9 in the right extreme. When we bring it down, when you automatically bring the cutting points down, you will be able to get, here it is going to be 9, here it is going to be 11, 7, and in the other way it is going to be 12, and in the other way it is going to be 9. So these are the 6 cutting points which we are able to see in the top view of the hexagonal pyramid. So the cutting points from the horizontal cutting plane in the front view is being indicated by 7, 8, 9, 10, 11, 12 in the top view. Now all these points are to be brought to the isometric projection. So for that, what we do is, here we need to draw lines along these points. Along 10, 11 they have drawn a horizontal line. Similarly along 7, 8 here they have drawn a horizontal line. along 6, 3, there also you can draw a small line. Similarly, you can also draw a vertical line along 1, 5, similarly 4, 2. And 7 we can draw a line, 8 we can draw a line. So wherever we need to find the points, we can draw the projection lines in this box. So now this box is going to be transferred over here. We are going to transfer the box to the top of our isometric box, all these points. So here it has been done in that way. You can see that we have drawn all these horizontal and vertical lines. You can see that small e, h, f, g, that is all being indicated over here. Small e, small h, small g, small f, all small 4 square like structure is small box like structure. E, F, H, G is also being drawn over here in the top of the box. Similarly, the horizontal vertical projection lines are also being drawn over here. After drawing, why we draw all these horizontal and vertical projection lines is only for indicating all these 7, 8, 9, 10, 11, 12 cutting points. We wanted to mark these cutting points in our isometric view. So for doing that, we are transferring the correct accurate location of these cutting points in our isometric view. For that, what we do is we draw these horizontal and vertical projection lines, and when we draw horizontal and vertical projection lines in our box ABCD, we do transfer the same to A1, B1, C1, D1. There we again draw, as in this horizontal vertical projection lines, here also we draw horizontal and vertical projection lines. And how E divides over here in this line, EH, accordingly here it divides. Similarly, FG, how it divides over here in this top view box, accordingly here FG will be dividing in the isometric top view, top box. Similarly, the cutting points as well, 7 and 8. Accordingly, you can see how the 7, 8 is being pointed over there. Similarly, 12, 9, 10, 11. 12, 9, 10, 11. So all the points are being indicated as in the small box in the given top view. Accordingly, here it has been transferred in our isometric top box. After marking all the cutting points 7, 8, 9, 10, 11, 12, we can join that by continuous lines, because in the top we will be able to see all the edges, as the solid is being cut in a horizontal way. It is a horizontal cutting plane, so the solid will be cut by using a horizontal cutting plane. So after cutting the triangle, or after cutting this hexagonal pyramid, when we see from the top, we will be able to see all the points. So that can be drawn by continuous lines, continuous bold lines. So all 7, 8, 9, 10, 11, 12 can be joined by using continuous lines. Then in the bottom, we can join in the bottom 1, 6, 5, similarly until 2, 1, 2, 5, 6 we can join continuously. While the points 3, 4, we are not, it is not going to be visible, as it will be in the other side of our board. So those points 3, 4 will not be visible from our view. Those points, as it is a solid, it is a hexagonal pyramid. So this solid, we will not be able to see those points 3 and 4. So whatever the lines which are joining the points 3 and 4 is being given in dotted lines. You can see that 5 is connecting 4, which is in dotted lines. 3 is connecting 4, which is also going to be in dotted lines. Similarly, 2 is connecting 3, which will be in dotted lines. Similarly, 4 we connected to 10, 3 has to be connected to 9. So that is also provided in dotted lines. So this is how we need to connect by in our isometric projection. All the visible edges are to be connected by dark lines, while the invisible edges we need to mark it by dotted lines, or even we can leave them away. If at all in certain books we can see these points 3, 4 will be ignored. instead of providing it in dotted lines, they just ignore those invisible edges, invisible corners. Okay, so in this way, after that we have to join the bottom view and the top box. The points 5 and 11 is being connected, 6 and 12 to be connected, 1 and 7 to be connected. Similarly 2 and 8 must be connected in dark. As these points are clearly visible, we need to connect all these lines in dark. So finally we are able to get a clear isometric view from this diagram, which you can see. This is a clear isometric view of our problem. This is a correct solution for our problem, and this will clearly show you the entire view. In the bottom, we are able to see all the 6 hexagonal shaped points as in the top view, 1, 2, 3, 4, 5, 6, that we are located over here in the bottom. Initially, we need to transfer the points 1, 2, 3, 4, 5 and 6 here in this ABCD bottom box, and in the top from A, B, C, D we need to draw 80 mm as given in the problem. 80 mm will be the height of the cutting plane. So 80 mm from A to A1, B to B1, C to C1, everything is 80 mm. After drawing A1, B1, C1, D1, we can join. So in the top we are getting the box. Now in the top we need to mark all these cutting points. In order to mark all these cutting points, we are marking a small square EFGH. In order to make it mark it clearly, these cutting points in the top box, here we are marking a small square EFGH, and also some horizontal and vertical projection lines. We transfer all these horizontal, vertical projection lines as well as the small square over there EFGH, and then we mark the points 7, 8, 9, 10, 11, 12 in the correct location from the top view to the top box over here. After marking all these points, we can join again clearly to the visible corners. When we join to the visible corners, they have to be clear, continuous and darker. In the top as well, all the points are going to be visible, so it will all be darker. In the bottom alone, points 3 and 4 are invisible. So whatever lines which we are going to connect to the points 3 and 4, that must be either in dotted lines, or those points and edges can be ignored. So this is the way how to draw isometric projection for any solid, and this is going to be a frustum of a hexagonal pyramid. So today we have seen how to draw an isometric projection of a hexagonal pyramid. In another day we will further study about another topic, or we will solve another kind of a problem in the same topic. Thank you.